made a windmill. In introduction, we're going to talk about the forces it took, the masses that we picked up, and how the potential and kinetic energy transfers it took to power the windmill. Alright, with our materials, we had the metal for the fan blades and all that. We had a welder to tack everything together and put stuff on Bondo so we could smooth up all the fan blades so they'd fly smooth through the air. We had the paint so we could paint everything. Plywood so we had something to mount it up, all get on. The cab foam to absorb the resonating of the fan. The string to lift stuff, screws to hold it on, and then our weights in which we had to pick stuff up.
Yep. Okay, so we lifted, like he said, we lifted those two plus another one. The book, the mass was 4.8 grams, and it lifted it up all the way to the top of the windmill. The mass of the container was 6.9, and it got off the ground, but it didn't go all the way up. So we figured that the mass has to be under 7 grams for it to lift all the way to the top of the windmill.
Alright, so what we did for force is we used a cattle fan that pushes 2,000 cubic feet per second, and it's what made the book and the weight pull up. But like Jerad said, it didn't go all the way up because it doesn't push enough air. So that's what we used for force. And finding force is just air hitting the fan.
With our potential and kinetic energy transfers, we had electrical potential energy to power the fan, and with that energy, it went to kinetic, which was blowing the air through the fan, in which it made to turn the fan blades. And which that went to kinetic or mechanical energy, which lifted the books and weights off the ground.
We conclude that it takes a lot of force to move that windmill, and we know what forces it takes to move it.
So, questions?
All right.